Hi, this is Eloise LeBlanc. I will be explaining the FRQ from 2011 problem number 5, which is part of the non-calculator section. The introduction to the problem states, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation highlighted below for the next 20 years. W is measured in tons, and T is measured in years from the start of 2010. To use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, which is t equals 1/4. So, to start off this problem, you have to look up to the top of the problem to see that dW over dt equals 1/25 times W minus 300. This equation will be used to find the slope of the tangent line, which will then be able to find the equation to approximate the tangent line slope at t equals 1/4. So to do this, you already know that t equals 0 to find it at the initial conditions, but then you need to find W, which according to the problem above, it says that it is 1,400 tons. So you plug it into this equation, which you get 1/25 times 1,400 minus 300, which equals 44. This will be the slope of your line tangent to the curve when t equals 0. You can write an equation for that tangent line. So using all the initial conditions, you can write this equation, which with the newfound slope too, which you get this, which is in point slope form. But I like to change it to slope intercept form, but that's just personal preference, and you do not have to do that if you do not want to. What you're trying to find for the problem itself is t equals 1/4, the amount of waste at t equals 1/4. So to do that, you wanted to plug it into this equation. So you want W at t equals 1/4. So you just plug everything in. So W equals 44 times 1/4 plus 1,400, and which you eventually get equals 1,411 tons of solid waste, which is your answer to number 1, or A, sorry. Okay, on to question B. This one asks us to find the second derivative in terms of W, and then use that second derivative to determine whether your answer in part A is an underestimate or an overestimate of the amount of solid at t equals 1/4. So to do this, you have to first start by differentiating this equation, which is the first derivative, to get the second derivative. Now I'm going to simplify it a little bit more and distribute the 1/25 so it's an easier function to work with. Once you're at this part, you have to keep in mind that you're differentiating in respect to t, in respect to t, and so once you differentiate, you get 1/25 of dW over dt minus 0, but because a constant, any derivative of a constant is just 0. You are doing this because this portion right here of dW over dt, because of implicit differentiation, you have to realize that since you're differentiating in terms of t, in respect to t, and in terms of W, you have to put this right next to it. So then you already know this portion because from this here. So you can just plug that in. Oh, sorry. And then you get 1/25 times 1/25 times W minus 300. Once you're at that part, you can just simplify that and get 1 over 625 times W minus 300. Now we have to see if our answer from part A is an overestimate or an underestimate. So in part A, you use a tangent line approximation. So the way to tell if it's over or underestimate is to see if the function W's graph is concave up or down. So to tell concavity is by using the second derivative, which you have solved for already here. When you're using the second derivative, if you plug in a value here, if the whole second derivative becomes positive, then it is a concave up function. And then if it's negative, if you plug in a value and then it comes out to be negative, then it's a concave down. So we know that W at the minimum is 1,400 according to the information that was already given to us, and it says that it is an increasing function, which means that 1400 is the minimum. So any number after that would not be lower than 1400. Any value after that in the function would not be lower than 1400. If you plug in 1400 into this function, you get, if you plug it into here, you get a positive number. And so then that would mean that it is concave up. So, and any number after that, since we are only increasing, and it is only subtracting 300 for every time, will be concave up. So the whole function is concave up like this. Using this, you can tell if it's an underestimate or an overestimate. So if you see this graph here, if you draw a tangent line to any point on this graph, it is under the curve, right? So that would mean that any point here or here or here would be lower than the actual point that on the graph, making this 1411, which is your answer to part A, tons, due to the concavity being upwards. So on to part C. This question asks us, find the particular solution w equals w of t to the differential equation dw over dt equals 1/25 w minus 300, which we have been working with almost the whole problem. So to do this, you have to separate the term. You have to divide by w minus 300 and then multiply by d of t to get everything on each side. Find a particular solution, or any solution to a function. When you have only the derivative, you have to integrate it. So use integration, which after you integrate, you get ln of w minus 300 equals 1/25 t plus c. It is very important to write the c, because you will get many points off if you do not use this. Okay, some of you might be wondering why I'm using parentheses instead of absolute value signs on these. It's because we know that our minimum value for w is 1400. So you can't go any lower than that. So if you only subtract 300 from any number equal to or greater than 1400, you will not get a negative number. So you do not need to worry about absolute value. So now that you have this equation, you have to solve for w, because that's what you're asking. They're asking of you. So you put an e to both sides, so then you get rid of the ln. So then you get w minus 300 equals e to the 1/25 t plus c. But then this all equals also e to the 1/25 t times e to the c, according to rules of exponents. So this function right here is any constant, because you don't really know this constant yet, and so anything e to the c is a new number, but it's still a constant that you will use later, so you can just replace that with c. So what you get now is w minus 300 equals c e to the 1/25 t. Then you just add the 300 over, plus 300. So you get w equals c e to 1/25 t plus 300. So however, now you still don't have the particular function yet. So you still need to find that c to get one of the particular functions. So that's when you use the conditions that were already given to you, which is that w of 0 equals 1400. So you plug that in, so you know that w equals 1400 equals c e to the 1/25 times 0 plus 300. So then you keep solving that, and 1100 equals c times 1, because e to anything 0 is 1. So you get that c equals 1100. So these are what you have found. You found this already, and you found that c equals 1100. So using this, you just plug it in, and you get w equals 1100 e to the 1/25 t plus 300, which is your final answer. So that is the end of the problem, the whole FRQ number 5. And so I will be putting up another link to another video that explains this problem. So then you can look at this one, the other one too, if you feel like this one has left anything out. And good luck on the AP test.